Up to this point, we've just been using single variables in order to store individual data values. It's also possible to group together multiple data values into a single array. So each element in the array must be the same data type, so therefore you can have an integer array, a float array, a char array, for example. And the elements in the array are stored in a contiguous memory address in RAM and can be accessed individually using the relevant index number. So it's very important that you remember that C and C++ arrays are zero indexed. So the first element in an array is indexed 0. So this is different from other languages where the first element in the array will have an index of 1. So when we create an array, we specify the number of elements in the array. So in this example, int is a data type, so this is an array of integers. And then we use this square bracket syntax, and then the size is inside. So here we've created an array with the so this is the name of the array, so it doesn't have to be, this can be anything. So here I've created an array with the name array, 5 elements long, if you will, each of integer data type. And then you can access each element in the array individually by using the correct index. So as it's 0 indexed, the first one is 0, then 1, 2, 3, 4. So you just need to get used to this syntax. So this is array, then in 4 here, that's the last element in the array. So here we can assign the value 56 to the last element in the array, and then we can also read values from an array. So in this example, I've created another integer value, and they're going to assign it with the value that's currently stored in array 2. So that's the actual say middle value in this array of size 5. So if an array is uninitialized, its contents are undetermined, and this can lead to problems when they're used. So it's therefore good practice to initialize an array when declaring it. So there's different ways of doing this. So you might want to set all the elements in the array to 0. So this, when we define our array, we can use this syntax, and that just means that all elements inside that array will be given an initial value of 0. Or you can individually initialize each element with a specific value. So we've got the same curly braces here, and then there's this comma separated list of values. So in this example, that's 0, 1, 2, 3, 4. So it does them in order, the index just goes in order. But here, in that last example, we've actually said here that we've got 5 elements in this array, but we don't actually have to do that. If you're initializing the array with values, you can leave this length empty, and then the compiler can just work it out implicitly from the number of values that you give to this initialization list. So in fact, we've come across strings before, and we've been doing hello world and things like this using printf. Well, strings are actually just arrays of chars. So a char represents a single character, and a string is kind of multiple characters. So it's essentially just an array of characters. So the array contains each individual character in the string followed by a null terminator. So a null terminator is 0 in the ASCII code. So this is the first thing, the first thing in the ASCII table. It's a null terminator, and it tells us when the end of the string is. So for example, when you wrote, if you wanted to create a string, so this string I've called MSG for message. So I've left the size blank because the compiler will figure out the length of it, and it's of type char. So when you see a char and these square bracket syntax together, that's kind of defining a C-like string. And then here I've just initialized it with hello. So we're using these double quotes. So when this is created, we've left this size empty. So it's actually, the compiler actually create, this is going to have 6 elements. So we've obviously got 5 letters here, but it actually uses I've just realised these numbers are wrong, so that should be 4, 5. So this array is actually going to have 6 elements in the array, 0 to 5. So each, so message 0 will be H, message 1 E, 2 is L, 3 is L, 4 is O, and then 5 will contain this special null terminator. So you have to, to write that, because if you write 0, it's going to think you're using they talk about the character letter, the number 0, the character 0. So it's \0. So that we don't really see this. That just tells us that just tells the compiler that that's the end of the string. So we call it a null terminated string. So let's briefly talk about memory, because when we create a variable, it's essentially stored in RAM. So each variable will be stored in a different slot in RAM. So every variable's got its own address. So each RAM address actually corresponds to 1 byte. So this is a byte addressable RAM. But an int is 32 bits when we use the compiler. So 32 bits is obviously 4 bytes. So each integer will take up 4 bytes of memory. So imagine this is some part of RAM. So these are some random memory addresses. So for example, when you create a variable, int value equals 45, we've assigned the value 45 for that. It's going to be 4 bytes. So these 4 slots in memory will contain the value, the 32-bit value, what corresponds to 45. And then we might create another variable. So in this example, we're going to store 99. So then the next 4 slots in memory will be used to store that variable. So when you create an array, it's essentially just, it's an extension of that idea. So we're just storing multiple slots in memory next to each other. So in this example, we've got an array, 5 values. We initialized it 100, 200, 300, 400, 500. So just for example, because this is a memory address. So if this is the first address, that will be that will correspond to the symbol array 0. So it's obviously the index 0 and contains the value 100. So the 4 bytes starting here will contain the value, the 32-bit value 100. And then the next, so that's this element here. So this next element, so that's index 1, represented by the symbol array 1. That's actually going to be, you need to shift, the address is going to go up by 4, because there's, so 0, 1, 2 and 3 are used to store the first value. So this next value will start at 4. And the same again, so that'll take up 4 bytes. So the next variable will be at this address, what again is incremented by 4, and so on. So the next one, 400, will be stored in this address. So in each one of these addresses, it's plus 4 from the previous one, because each of these elements is an integer which takes up 4 bytes in memory. So if you look at the RAM in the memory map, you'll see these are the addresses. So when you create a variable, they're stored in these address ranges here. So this is where the RAM lives inside the microcontroller memory map. So let's look at this quick example. So here in this source code, we're going to, in our main loop, we create this array. We initialized all the values to 0. So we've got an array, 10 elements, 10 integers, all initialized to 0. And we're just going to loop through. This is, arrays and for loops go hand in hand. So you have a for loop here, what's going to iterate over this I from 0 up to 9. And then we can set I, we'll use it for the index of the array, and then we'll also just, in this example, we'll also just square I and store it back in that array. So this array is going to end up containing all the square numbers. So if you compile and run that, you'll see this will be printed out. So you can see in the first instance when so this is when I is 0, I is 1, 2, 3, 4, and so on. We'll keep going up to 9. So that shows how you can calculate some value and store it in an array.